Hello everyone, this is Sravani. Today let's talk about searching techniques and data structures. Before that, let's go with a small introduction what is meant by searching techniques. For finding the given value position in a list, we use the searching techniques. Firstly, we know about what is searching. Searching is the process of finding a given value position in a list of values. It decides whether a search key is present in the data or not. It is the algorithmic process of finding a particular item in a collection of items. It can be done on internal data structure or an external data structure. There are two kinds of searching techniques. One is linear search, which is also called as sequential search, and the second one is binary search. Today, let's talk about linear search. Linear search is the simplest searching algorithm. It traverses the array sequentially to locate the required element. It searches for an element by comparing it with each element of the array one by one. So it is also called as a sequential search. Linear search algorithm is applied when no information is given about the array, the given array is unsorted or the elements are unordered, and when the list of data items is very small. Linear search algorithm. Let us consider there is a linear array A of size n. Linear search algorithm is being used to search an element item in this linear array. If search ends in success, it sets lock to the index of the element, otherwise it sets lock to -1. Then linear search algorithm is as follows. Implementing linear search. Following are the steps for the implementation that will be followed. Transverse the array using a for loop. In every iteration, compare the target value with the current value of the array. If the values match, return the current index of the array. If the values do not match, move on to the next array. If no match is found, return -1. To search the number 5 in the array 8, 2, 6, 3, 5, linear search will go step by step in a sequential order starting from the first element in the given array. The element 5 is compared with the 0th index element, that is 8, where 5 is not matched with the 8, so it checks with the second index element, which is 2. 5 is not matched with the 2 also, so then it goes for the third index, and so on till the element position is found. Linear search operation code is as shown. Time complexity of a linear search. A linear search runs in at first linear time and makes at most n comparisons, where n is the length of the list. If each element is equally likely to be searched, then linear search has an average case of n plus 1 by 2 comparisons. But the average case can be affected if the search probabilities for each element vary. Linear search is rarely practical because other search algorithms and schemes such as the binary search algorithm and hash tables allow significantly faster searching for all but short lists. In linear search, worst case performance is order of n, best case performance is order of 1, average performance is order of n, worst case base complexity is order of 1. Best case. In the best possible case, the element being searched may be found at the first position. In the case, the search terminates in success with just one comparison. Thus, in best case, linear search algorithm takes order of 1 operations. Worst case. In the worst possible case, the element being searched may be present at the last position or not present in the array at all. In the former case, the search terminates in success with n comparisons. In the latter case, the search terminates in failure with n comparisons. Thus, in worst case, linear search algorithm takes order of n operations. Thus, time complexity of linear search algorithm is order of n. Here, n is the number of elements in a linear array. Linear search efficiency. Linear search is less efficient when compared with other algorithms like binary search and hash tables. The other algorithms allow significantly faster searching, whereas linear search can't. Let's go with a small example in linear search. We are given the linear array with the elements 92, 87, 53, 10, 15, 23 and 67. Element 15 has to be searched in it using linear search algorithm. Now, linear search algorithm compares the element 15 with all the elements of the array one by one. It continues searching until either the element 15 is found or all the elements are searched. Step 1. It compares the element 15 with the first element 92, whether the element 15 is present at the 0th index or not. Where 15 is not equal to 92, so the required element is not found, so it moves to the next element. It compares element 15 with the second index element, which is 87. Since 15 is not equal to 87, so the required element is not found at the second index also. So it moves to the next element. Step 3. It compares the element 15 with the third element 53. Since 15 is not equal to 53, so required element is not found, so it moves to the next element. Step 4. It compares the element 15 with the fourth element 10. Since 15 is not equal to 10, so the required element is not found, so it moves to the next element. Step 5. It compares the element 15 with the fifth element 15. Since 15 equal to 15, so the required element is found. Now it stops the comparison and returns index 4 at which the element 15 is present. So the position of the element 15 is 4th index. Program for a linear search is as shown. As shown above example, it was done in the same way. Applications of linear search. Linear search is usually a very simple to implement and is practical when the list has only a few elements or when performing a single search in order in an unordered list. When many values have to be searched in the same list, it often pays to pre-process the list in order to use a faster method. For example, one may sort the list and use binary search or build an efficient search data structure from it. Should the content of the list change frequently, repeated reorganization may be more trouble than it is worth. As a result, even though in theory other search algorithms may be faster than linear search algorithm like binary search, in practice, even on medium-sized arrays around 100 items or less, it may be infeasible to use anything else. On larger arrays, it only makes sense to use other faster search methods if the data is large enough because the initial time to prepare sort the data comparable to many linear searches. Thank you.